Test for the convergence of the series 1 plus 3 by 7x plus 3 by 6 by 7 into 10 x square plus 3 into 6 into 9 by 7 into 10 into 13 x cube plus so on, where x is greater than 0. See, here they are given first term, second term, third term, fourth term, sum of the series. Are they given nth term in the series? No. So we have to find out the nth term. For this, observe the series. This is the fourth term. Na? So if you remove this last term in the fourth, last product in the fourth, you have, you see, 3 into 6 by 7 into 10. Is it contained in second term? Yes. Previous term? Yes. Now here 3 into 7, it is containing. Now you remove 3 by 7 here, 0. Is there here? Now extra what we have? 1. So is this one belongs to enter this series to write the nth term, means is it required this term? No. So like this sometimes they will give 1 or 2 extra terms. We can neglect these terms. Then you can write the nth term freely. Now from the last term, you see, this is 3 into 6 into 9. We have to write the nth term. Third term 1, 2, 3. Third term is containing product of 3 terms. What about the nth term? It contains product of n terms. This is a repeated series form. So now nth term we want to write now. For that, what they given? 3, 6, 9. So what is the common difference here? In each term 3. So write on 3n. Put n is equal to 1. This is 3. Put n is equal to 2. 3 into 2, 6. Put n is equal to 3. 3 into 3, 9. Satisfied. So nth term is in the numerator 3n. Now going for the denominator, it is 3. You have, it is 7, 10, 13. So common difference is here 3. Here 3. Okay, common difference is 3. So you have to write again 3n. 3n only. But here you see, what is the first term here? 3. But here you have 7. So add 4 for this. Now check it. Check this term is the nth term for the denominator or not. We have to verify. Put n is equal to 2. 3 into 2, 6. 6 plus 4, 10. N is equal to 3. 3 into 3, 9. 9 plus 4, 13. Yes. So this is the our nth term. Since x greater than 0 and this numerator and denominator both are positive, so this series is a series of positive terms. Now it is in repeated series form. So you cannot apply like limit comparison test, geometric series test, p series test. So we have to go for ratio test. In the ratio test, you required to find the limit of un by un plus 1. So un plus 1 I want. Earlier we discussed this is repeated series form. So this contain nth term also. So 3 into 6 into 9, so on 3n. What is the next term? How you will write the next term is common difference is what you have? 3. So add 3 for this. And for this also you add for 3. Then you will have 3n plus 4 into 3n plus 7. Now I want un by un plus 1. Un by un plus 1, you see what is the common terms you have up to nth term. So in the numerator up to 3n getting cancelled. In the denominator up to 3n plus 4 getting cancelled. Remaining you have x to the power of n by x power n plus 1 becomes x power n getting cancelled. 1 by x is the latter. This denominator term 1 by 3n plus 3 by 3n plus 7 reciprocal if you written 3n plus 7 by 3n plus 3 you will have. Now apply the limit on both sides. Limit n tends to infinite. This is the quotient is here n power 1, n power 1. Both numerator and denominator have the same degree. So as n tends to infinity you will get here coefficients, that is 3 by 3 into 1 by x. 3 by 3 into 1 by x. Which 3 by 3 getting cancelled, you will have 1 by x. 1 by x is a limit. Of course, you can do one more thing. Take n common. Then you will have 3 plus 7 by n. 3 plus 3 by n. N cancel. As n tends to infinite, 1 by n goes to 0. So 3 plus 0 by 3 plus 0. Which gives same only. Okay. Now, this is L. You don't know x. But they are given x is greater than 0. If x greater than 0 means 1 by x is maybe greater than 1 or less than 1. Okay. Or else maybe is equal to also. No? So you have a different chances here. If greater than 1, what we can say, if it is greater than 1, limit is greater than 1. If less than 1, the series is less than 1. 1 by x is, 1 by x is less than 1. So by ratio test, if L greater than 1, that is 1 by x greater than 1, series is convergent. If 1 by x less than 1, series is divergent. Now x is equal to 1 maybe, na? So put 1 by x is equal to 1 in this case. That implies x is equal to 1. Where we have to substitute x is equal to 1 means entire in the given series. The given series is what here? This one. Even 3, 6, 9, so on 3n by 7, 10, 13, into 3n plus 4 into x to the power of n. Put x is equal to 1. Again what you have now? This is the our series. Just you don't have x term. Now again it is in repeated series form. Now. So what you have to do? You need to find out un plus 1. Yes, this will become a un plus 1. Now un by un plus 1 if you done, then you will have this one. So whenever the given series in repeated series form, directly you substitute x value in un by un plus 1. If you substituted un by un plus 1, you will have like a limit n tends to infinite, this n getting cancelled. Again you will have instead of 1 by x, here we have to substitute now. X value is 1, so 3 by 3. 3 by 3 is equal to what? 1. 3 by 3 is equal to 1. That is L is equal to 1. So in the ratio test, if limit is equal to 1, what we can say? It is fails. Ratio test is fails. So we have to go for Raabe's test because the limit does not containing E. Now in the Raabe's test, we need to find n into un by un plus 1 minus 1. So that is equal to n into, what is un by un plus 1? We have 3n plus 7 by 3n plus 3 minus 1. LCM is here 3n plus 3. Now this will become 3n plus 7 minus 3n plus 3. So this 3n getting cancelled. 7 minus 3 will become 4. 4 into outside you have n. So this is 4 into n. Now numerator and denominator both have a nth term. Right. So limiting on both sides. Limit n tends to infinite taking on both sides. Then it will happens. The numerator and denominator have the both same degree. In this case you will get the coefficient as a limit, that is 4 by 3. Or else you can take n is a common. N getting cancelled. This is 3 by n goes to 0 as n tends to infinite. So finally you will have 4 by 3. This 4 by 3 is a limit which is greater than 1. Therefore summation un is convergent. What we can say, when the limit is greater than 1, now we are doing in Raabe's test. So if L greater than 1, series is convergent by Raabe's test. So finally what we can say means the series is convergent for 1 by x greater than 1, less than 1 divergent, is equal to 1 also convergent. That is why you are written 1 by x is greater than or is equal to 1 convergent, 1 by x less than 1 is divergent. This is the Raabe's test method.